Hello, we have an indeterminate beam problem here today. It's called a propped cantilever beam with a distributed load of 4 kg per foot. It has a fixed support at point A and a roller support at point B. And the questions we're given say we are to calculate the reaction at the roller support here. We are given E, the modulus of elasticity, as 29,000 KSI, and I, which is the moment of inertia, as 1,200 inches to the fourth power. So we're asked to calculate the reaction at this point here. And like I said, it's an indeterminate beam, and so you have more unknown than the number of equilibrium questions available to you. So we have 3 equilibrium equations, and you have 4 unknowns. 4 unknowns, 3 unknown here, plus this 1 unknown, that make it 4. But because we do not have a horizontal force on this beam, we can safely eliminate the horizontal reaction here. So that becomes 2 unknown on this corner and 1 unknown here. So that becomes 3 unknown. So because you eliminate the horizontal reaction, you also have to eliminate the horizontal equilibrium equation from the 3 equations of equilibrium. So you have actually 2 equilibrium equation and you have 3 unknowns. So you need additional equation to be able to solve this problem. So the way you approach is, we are going to use the deflection method, and as you can see, you break this indeterminate problem into a simple determinate problem. So, and you can add them up after the fact, and then you come back to what you started with. So this is what we just did here. So I broke this up here. On this first section, section 1, I have just the beam and the load. And so when you have that, it causes a deflection, a negative deflection here, as you can see at point C. Okay, the second part, you take out the load, and you introduce a prop, a support at point B, and you can see it deflect the beam upward. So that gives you a positive deflection here. So the concept is that when you add these two deflection, these two delta, you should come back to 0, which is what you want here. You don't want that to deflect, any significantly. So that's what you have. So you have the equation of deflection. You can get this equation from your manual, the AISC steel manual, in the section 3-23. You can find it there. All right. So here, like I said, it's a negative deflection here. It's causing a positive moment on the top and a negative moment at the bottom. And so you have a negative deflection. So you're going to introduce that negative here with a sign, with a negative sign here. And so that becomes here W, your W, divided by 24 EI, parentheses, x raised to power 4 minus 4L raised to power 3 plus 3L raised to power 4. All right. So that's your formula for a deflection, for a conditions like this. Okay. Now, that's our first situation, this one here. For the second situation, which is this one, when you go to the book again, you will find a formula that matches this, and it's like this. It's going to give you as P B raised to power 3 E I. Okay. So now you have this formula here. So the point is, you want to equate these two formula and have them as 0. Okay? So you want to sub them individually, and then put them together. You are going to have the same thing. So now our P here represent as BY. So you can actually take this one out and become your BY. Now, 4 kg per feet all the parameters in these equations, you can convert it to the same unit. This and this is already in unit of inches. So you can convert this and the length to unit of inches. So when you convert this to unit of inches, it becomes 0.33 cube inch. Okay, 33 cube inch. So if you introduce that in here, because of space, let's just add it here. 0.33. Okay, this one we know over here. Here, x, our x is here. That's our point of interest. So it's 4 feet to the point of deflection, and multiply that by 12. That's 48 raised to the power 4. Okay. Here, 4 multiplied by L. L is the whole beam. The entire length of the beam is 13 feet. 13 multiplied by 12, that gives us 156. 156 raised to the power 3. Okay. And then the rest of here, you have 3 multiplied by 156 raised to power 4. Okay, that's the equation here. Now, that's the first part. And if you solve this, you are going to have, if you solve this using your calculator, you are going to have negative 0.42. Okay, that's what you're going to have, and it's in inches because your deflection is in the unit of length. Okay, in this case here, if you solve this, your by, put all these values in, you are going to have it in terms of by. So your by is going to be, your deflection on this point is going to be 0.012 by. Okay, so now you have the two. So the point now, you want to equate the two answer from the two beams. Okay, so if you equate that and you equate it to 0, so it's going to be negative 0.420 plus 0.012 by is equals to 0. All right, if you do the math, take this one to the other side and become positive, and then you divide this by this. So your by is going to be 0.42 divided by 0.0128. Okay, and that will give you 35 kips. Okay, so your by is 35 kips over here. And so that's your answer here. That's your answer here. And yeah, I think it's very straightforward. You can go over it again. Feel free to comment, ask questions. We'll be delighted to respond. Thank you.